we're looking at improper integrals, so this is an improper integral. And what we're doing on this is we're actually trying to see if this converges or diverges. And what we learned how to do last time was change this like this, just kind of change that to some letter like a B, and then do a limit. So what we're going to do is we're going to write this as a limit as B goes to infinity to begin with. Okay, now I think this one you got to do integration by parts on, and then we're going to do the integral from 0 to B, kind of our basic variable. That's not good. Leave me alone, whoever you are. Let me get that off. I apologize. Okay, so we have this, and then we're going to have to do this integral by integration by parts. This is a pretty basic parts integral then, okay? All right, so it looks like let's set u equal to x, okay, because that's an easy derivative, and the derivative becomes simple. And then I'm going to go dv is e to the negative x dx because that's an easy integral, okay? All right, so let's crunch this out then. So what's du? dx, okay, what's v? Yeah, make sure you got the negative in there, negative e to the negative x like that, okay? So we have that. All right, so what we're going to go ahead and do is we're going to go ahead and do the parts integral then. So we're going to do u times v, so that's going to be negative x e to the negative x, like that. And then we're going to subtract the integral v du, so it's going to be negative e to the negative x dx, like that. Now I'm just going to kind of set up an improper integral on this first of all, okay? Everything okay so far? Okay, I think we've done enough integration by parts. This is a pretty basic one actually. Okay, then let's go ahead and write this as negative x e to the negative x. Of course, you got two minuses. You can bring that minus out, so you'd have plus the integral of e to the negative x dx, like that. Okay, now what you're going to do is you're going to integrate from 0 to b. So you can do it like this if you want to. Since we're doing a parts integral, we can go ahead and evaluate that part at 0 to b now if we want to. You could also wait till the end, just integrate it and then do that. Then we'll do 0 to b there. And then we'll end up seeing if we can take the limit as b goes to infinity. Okay, so let's go ahead and crunch that out then. Okay, just kind of be careful with your signs and everything. You could bring the negative out. I'm just going to leave the negative in, I guess. So that's negative b e to the negative b, and then minus, and then I've got negative 0 times e to the negative 0, like that, when you evaluate that first part like that, okay? All right, now what's the integral of e to the negative x? Negative e to the negative x, okay, you got to have that negative in there, and then we're going to evaluate that also from 0 to b, okay? We're just going to clean this up and then see if we can do our integral on this then. So I'm going to write this as negative b over e to the b. That's just making the exponent positive. And then this whole thing becomes 0, so that's kind of nice. Okay, and then we'll have, that just goes to minus 0. I'm going to put that in there. Okay, then we'll evaluate this. So this is negative e to the negative b. You could take that negative out. That's probably what I should do, but it doesn't matter that much. So minus e to the negative 0, like that. Okay, if you want to leave the negative in, just be cautious about how you do that. Okay, so this is going to be negative b over e to the b. Of course, that's gone. Then this part right here, I'm going to write that as minus 1 over e to the b. Again, making that that exponent positive. That'll help with our limit. And then the last thing is, of course, this is e to the 0 is 1, so that's a minus 1, so that's a plus 1, like that, okay? So that's the integral is now done, and we've evaluated that. So look over that, tell me if you have any questions about the details on that. I could have factored some negatives out there too if I would have done that. So now what we want to do is, since we're doing an improper integral, we want to do the limit as b goes to infinity of negative b over e to the b minus 1 over e to the b plus 1. And what you're really doing is you're doing the limit laws. I'm not going to show the step because we've done that so much, but you're doing the limit of each part right there, okay? And you can do this mostly in your head. This one is one, if you think about this one, and if you just kind of look at that, you would have like an infinitely big or infinitely small negative number, and then you would have something infinitely big in the bottom. But you got to think about this one a little bit. Okay, it's kind of like which would be bigger, just an infinity or e to the infinity? That'd be way bigger. Okay, so the idea is it doesn't really matter what that is, even though that's infinite. This is like getting infinite bigger and faster. Does that make any sense? So that's actually going to go to 0. Okay, that's kind of a weird one. So that's going to go to 0. Okay, how about the next one? What's it going to go to? That's more obvious. That's like 1 over infinity. You know, we know that you're going to have that form, so that's going to go to 0. So we're left over with 1. So that means the answer to this integral is going to be equal to 1 then. Okay. And again, what we're doing is we're doing an area under a curve, but we're doing the x value is getting infinitely big like that, but still that limit converged to a precise answer like that. Okay, now that's one that's got parts. I think all the other things I did last time in class didn't have integration by parts. Okay, does that make any sense? Okay, so improper integrals, you're going to use that actually, this idea quite a bit in the next chapter. So that'll kind of close that off. Any questions about anything on that? Okay.